You are listening to the Break Time Tech Talks podcast, a bite-sized tech podcast for busy developers, where we'll briefly cover technical topics, news snippets, and more in short time blocks. I'm your host, Jennifer Reif, an avid developer and problem solver with special interest in data, learning, and all things technology. There are a few things sitting on my radar for future content that I hope to spend some time exploring and learning. Two of those things are vector databases and AI agents. Now, both of these kind of dovetail really nicely together. We'll talk a little bit more about that, but vector databases are a key component of AI stacks, and I'd like to better understand how they work, both their strengths and their weaknesses. While AI agents are about using LLMs or large language models in certain decision-making scenarios. I read a really great article from Anthropic that goes into depth on the many different use cases and architectures for AI agents. To kick us off, though, I wanted to start this conversation with vector databases. Vector databases really took off when the beginning of the wave of AI started, mostly around the beginning of 2023. So ChatGPT released in the end or November of 2022, and then you really started to see retrieval augmented generation, or RAG, come into play in 2023. And this is really where vector databases started to excel and really just hit the market big time. As a database person, I know that they do store data differently than a graph, obviously, as with kind of any type of database, document databases, key value stores, relational databases, graph databases, so on. And I also know that vector databases are optimized for very fast retrieval of vectors, which are numeric representations of data. If you want to go into a little bit more detail on what vectors and embeddings are, I do talk about that in episode 10 of this podcast. So check that out if you want to get a background or a refresher on what embeddings and vectors are. Then vector databases store those vector representations. As with a lot of database vendors at the time, Neo4j also implemented vector support in the database to store and query vector data as well. That was not something that graph databases, relational databases, document databases, other types were naturally fit to store, but most database companies at the time started adding vector support so that then they could basically add these capabilities on as well and utilize vectors and run similarity searches. But my question is, how does a native implementation differ from a non-native implementation? These vendors that tacked on vector support to their databases, how is a native implementation different, better, worse, etc.? What are their strengths and their weaknesses with a first-hand experience? I have heard that native can be stronger in certain cases, which makes valid sense, right? I wouldn't want to put a graph into a non-graph database. They are designed for very specific strengths and then also have some weaknesses too. But I really want to know, what are those strengths of a native vector database? And then does that actually hold true for the data sets that I typically work with and the use cases I like to test out or explore? When is it actually better to have a vector database versus a graph database or another type of database? What use cases do they work well for? What data sets, what questions and problems and analysis do they handle really well, and others that they don't quite so much? These are the questions that I really hope to invest some time in answering by working hands-on with the technology, hopefully sometime soon. Again, I have a little bit of background, but I hope to dive deeper and actually play with the technologies, pull some data in, query it, explore it, maybe connect it up to some Gen AI applications and see where that takes me. The piece of content dovetails actually really nicely with this topic of vector databases because it's Anthropic's article called Building Effective Agents. Now, the article goes into a definition and says that the definition of agents varies quite a bit, which actually is what I'm aware of as well. It's what I've been exposed to. Depending on who you're talking to, you'll get different answers and different definitions of what an agent actually is. These vary from very autonomous, almost non-touched or non-intervention systems to something that's has a lot of interventions and gate checks and kind of other processes or other systems or applications that pop in and check or combine different answers and tasks that the LLM has completed. Anthropic also backs this kind of concept, or what I know, up, that says that agents, the definition of an agent varies quite a bit. Some will define it as fully autonomous systems, where others they'll define it as more prescriptive sets of steps with potential interactions from other systems, for instance, like human intervention. The article also talks a little bit about when and when not to use agents. They recommend the simplest solution and then only adding complexity as needed, which I am a huge fan of. Start simple first and then add on that complexity only as needed and only if you need it. So I really loved this approach. They followed up with that a few different times throughout the article. Start simple and only build in the complexity that you need and when you have to. Then they go into detail on the difference between workflows and agents. They separate the idea of more fully autonomous systems and more prescriptive sets of steps with layers of interventions, that being workflows, and then the more autonomous stuff being agents. And they give lots of different examples. They step through a ton of different use cases. They're very thorough, very comprehensive, and I really thought this was extremely helpful to see all the different ways that you can use this general concept of agents, but as they've separated workflows and agents in a variety of different scenarios. So lots of examples moving from most intervention heavy workflows to the most autonomous agentic systems and kind of everything in between. They start off with workflows with those that have the most intervention, things like retrieval augmented generation type of systems where you have a lot of an LLM completes a task, you might have a verification or a gate check before that response goes out. And then you might have an LLM completing a few different tasks and then bringing all those together and checking those and then summarizing them towards the end. So again, multiple steps that the LLM's doing, but some other interactions or intermediary steps in between. And then that kind of moves, once you get past all the workflows, and there are a bunch of them, then you move into kind of the agents, which are a little bit more autonomous, a little bit more where the LLM is making not only completing the tasks, but it's making decisions about those tasks and what it needs to do to complete those. And it goes into several more details, lots more examples on the most intervention of agentic systems to the most autonomous of agentic systems. Agents are at the base level some kind of LLM decision making. So there's some kind of decision making process going into the LLM's answers. And that's what agentic systems mean. And this is exactly what Anthropic's article backs up. But again, they're dividing that. The least autonomous segments or examples, use cases are going to be a little bit more like workflows, much more process oriented, multiple steps and so on, where the most autonomous send it something and let it do a bunch of things and spit out a response where there's very little intervention. Those are going to be more agentic systems. Again, it goes into that detail, supports everything that I've read so far. It clears my verification checks, if you will. And I thought this was really interesting, extremely thorough. It is probably going to be about a 10 or 15 minute read. So it does go into a lot of detail, but it doesn't take up too much of your time either, and really gives a fantastic overview of in-depth knowledge and all the different cases where agentic systems are used. As always, I'm constantly learning and exploring. Vector databases and agentic systems are something I hope to learn more about and explore for myself to actually realize the value and the way that they fit into the larger tech ecosystem, and of course, in Gen AI. Thanks for listening and happy coding.